Okay, Bismillahirrahmanirrahim. Uh, let's start with this new topic about the extraction of regular expression using state elimination algorithm. And this is the pictorial view of the scheme that we have to follow for the extraction of regular expression through the use of state elimination algorithm. So initially, some FA will be given to us as a input, and then at the next stage we will apply some pre-processing rules over it, and those are six pre-processing rules that we have and that we will study a moment after. uh, so after applying those pre-processing rules, then we have our FA normalized state. That FA will be given again as an input to this state elimination algorithm, which is an algorithm through which you can eliminate states in the given FA. And by eliminating those states one by one, finally you will reach at some state when your FA will have only two states. And when your FA will have only two states, then there is a step of extraction of regular expression. Basically, when your FA will be in a state when it has only two states left with, then the regular expression you will surely get in parallel automatically. So this is basically the idea or the scheme that we have to follow in this lecture. So this is pre-processing rules, and then we will study something about state elimination algorithm. So these are the basically the two concepts that we have to study here. So first, let's start with the pre-processing rules. These are quite easy ones. You can simply say easy peasy as we normally say to our kids. So, for example, if you have a FA like this, and if it has more than one initial states, then your duty is to convert that FA into another FA which can have only a single initial state, like this one. For example, here, so the rule is one start state. Our FA should contain one start state. So this is the FA in which we have two initial states. So how can we do that? We know the null transition from our previous lecture. So we can simply introduce a new state when we can call it initial state, and then we can introduce the null transition towards those states here. So this is the first rule. And the second rule is one end state. And the second rule is one end state. So here it is a similar concept, but with the final states. So final states, as you are seeing, are representing with this plus sign, and these are more than one final state. So you can do the same thing with this. If I also introduce another one, and uh, also introduce the null transition towards this newly generated final states, and in this way you can convert your FA with which has more than one final states into an FA which will have only a one final state like this. So using null transition as you already done in previous lectures. Rule number three. Rule number three is no multiple loops on a single state. For example, here on the left hand side, you can see initial state, final state, and this is the state on which we have multiple loops. One loop for A and one loop for B. So you have to remove these multiple loops into a single loop like this one. And this is A and this is B. So we can represent A comma B or A plus B, which means either A can go towards this way or B can go towards this way by using this loop. So this is the mechanism through which you can remove multiple loops. Now move on to the rule number four. No multiple paths, very similar to the multiple loop steps. So this is no multiple path. For example, if this is an FA like this, initial state, final state, and these initial and final are not necessarily for this case. These states can be any state. So for example, one path is with A, other path is with B. So these are the multiple paths going in the same direction. So what you have to do, you have to uh, remove it with single path, and then we can simply say that either A, either B, A comma B, or A plus B. So this is the way you can simply remove multiple paths into a single path. And the rule number 5 is unenterable initial state, which means, for example, this is the FA, and here in this FA we have this initial state in which an edge is entering, or in which an edge via this loop is coming toward this state, which is an initial state. And this initial is not necessary condition, it could be any state anyhow. So unenterable initial state, so sorry, so this is about only initial state, unenterable initial state. I'm not talking about other states, it is only for the initial state. So but we are seeing that some edge is coming into this initial state. So what we have to do, we have to remove this state. And how can we do that? Only by introducing null transition. So we can introduce another state and we can call it initial state, and then we can introduce an edge labeled with null transition. So it's a similar FA but introduced with the null transition. Or for example, if we have like this, a situation like this one, plus and minus, which means this is a state which is initial and also the final states, and it is in the form of a loop. So we can introduce this initial state and then we can introduce null state and so on. But the sixth rule is that uh, unexecutable final state, executable final state, which is this condition in previous example, but we have left this example unsolved here because we have to address this point here. So executable final states, which means that no final state can have an outer degree. For example, here this is state, but this is the final state, and it has an outer degree with an edge labeled with B. So how can we remove that? So you have to introduce another state, then you can call it final state, and you have to introduce null transition here. So by removing this, you have removed the status of this final state, but again we have an initial state. We have an initial state in which an edge is coming into it, which is this previous case of rule number 5, unenterable initial states. So but this initial state has in degree, you can say, in terms of graphs. So we have also have to remove this one by introducing another state with null transition. So these are the 6 processing rules that we have to apply in this step. And after applying these steps, we will have our normalized FA. And now the next step is the state elimination algorithm that we will see now. So state elimination algorithm, what is this one? So let's see. If we have this FA represented with states 1, 2, and 3, I didn't mention initial and final states explicitly because these are the things that we already have done here in these processing rules. So I want to give you clear concept, so that's why I didn't mention these things here. If there is initial state and final state, then we have to look for the pre-processing rules first, and then we can uh, reach at this state elimination algorithm after the application of the processing rules. So for example, this is an FA, and now we this is the phase of state elimination algorithm, which means you have to remove the states until you reach at a state where you will have an FA with only 2 states. But here we have 3 states, so this is not our state actually to stop. So what we have to do, we have to remove some um, state from here. So for example, you can remove any state, 1 or 2 or 3, it's up to you. Okay, this is something that you have to keep into your mind. And here I am removing the second state. Removing 2 would be. But what is the rule? This is the rule written here. What you have to do, the state which you are removing, you have to consider its incoming edges and outgoing edges, uh, and you don't have to consider loops. So this is the formula written here. Total parse edges that we will have after removing this state 2, for example, is equal to, this is the general formula that you can apply on any removal, and this is total pass is equal to incoming edges multiplied by outgoing edges excluding loops. So for example, now I am going to remove this state number 2, and if I am going to remove this, what is the outer degree and what is the in degree? It is 1 and it is 1. So 1 cross 1 is equal to 1. So 1 would be the edge after removing this state from this FA, like this way. For example, this is the state 1, this is the 3. Now state 2 is removed, and this is the A, and then after that one I will take the input B. So I have to only represent one edge, which was I concluded from this formula, that after removing state 2, what would be the number of edges I have to represent between the remaining states? Only one. And I have to look over the inputs, which is A, and then after that it's B. And then you can write it in concatenation that from 1, after taking A, B, I will reach at 3. So this is very much same FA with respect to this one. And this is also the regular expression AB for this FA. Okay, this is just a short example, but now this is another case, another example. That's why it is written here and or. So for example, I have this FA, the same FA, but I have introduced a loop here, A, and a loop with label A and then B. And now I want to remove this too. So here inner degree is 1, outer degree is 1, and I don't have to count this loop because I have already written here excluding loops. So it is again 1 cross 1 is equal to 1. And so removing 2 would be 1 and 3. And after removing this state, A, but you have now, when you have to write the label of the edge, that is something different. In writing the label of the edge, uh, you cannot ignore these loops. You have to consider, because you have to build the regular expression finally. So a star, a star is due to loop. When you have a loop, then you can write something with star. So a, because it is something iteration, it is something repetition. So a star, and then B, that you have to write it here. And this is the end for this case. Now another case. Here in this case, I mentioned and or. If you have a another state 2 with loop, and you have multiple edges going toward different states, and after now if you remove 2, then what is the in degree? 1, outer degree is 3. So 1 cross 3 is 3. So now I have to introduce 3 edges in my resultant FA after removing this state 2. So removing oblique eliminating 2, we have, so I know that after removing this 2, I have a star, and B one edge, a star, and C another edge, a star, and D another edge, that I have represented here. And now I have, for example, how many states? 1, 2, 3, 4. So anyhow, I still have to this is just an example that if you have the status like this, then you can do the things uh, in this way. Because I don't have any final state, if to conclude this, I have to introduce some final state here. But this is a short example, so that's why there are many concepts I didn't discuss here. But this is the case for some state if they have the things like that. Another uh, example. State 1 is coming here to with this is 3 a comma b c and d, and if I want to remove this state number 3, then incoming is 2, outgoing is 3, so 2 multiplied by 3 is equal to 6. So if I remove this state number 3, how many number of edges I have to introduce? 6. So you can focus on my cursor because I am continuously um, pulling cursor here and there so that you can understand the things. So anyhow, so let's move on. So this is, if I will remove this state, then what are the edges? A into a plus b whole star, and then b, this is one edge which is represented here going towards 4. A plus b whole star into c, this is another edge going towards 5. It is represented here. A plus b whole star, d going towards 6. It is represented here. And then from 2, b, a plus b whole star into b going towards 4. So I can represent it here b, a plus b whole star b, and I can label it with a new variable x. So this is also an option for us. If our regular expression is going lengthier and lengthier, then what we can do, we can uh, introduce another variable, and we can say that this thing is equal to this thing, and then here you can introduce that newly generated variable. So x is what? B, a cross b into b, uh, which is this path. B, a plus b whole star b, this one x. So you can see label here. B, a plus b whole star e going toward y, or c. So this is y. So you can represent it here. And similarly, you can represent an edge with z. So these are the cases that you can do during state elimination algorithm. So now we have seen FA with pre-processing rules and a state elimination algorithm. What is state elimination algorithm? You have seen that. You can remove some state, but you have to see the incoming edges and outgoing edges, and then you have, after multiplying, you will get some answer. That is the number of edges that you have to introduce in your next FA. So after applying state elimination algorithm until the stage in which your FA has two states, then you have to stop, and then you will get your regular expression automatically. For example, here you can see I am getting my regular expressions, x, y, z, or whatever. Still, the states are many, so I cannot conclude something finally. But to understand this thing, now we will start with some proper example. So here in this example, we have this FA, some state. This is the initial state in between. B is going here, A, B is coming here. A is going toward the final state, and A comma B is going toward this initial state. So now this is a proper example. So first, now we have the initial states and the final states. So what we have to do first? First, we have to apply the pre-processing rule. That is the first step in state elimination algorithm if we want to get irregular expression from this FA. So this question is about getting regular expression from the given FA. So for what we have to do first, we have to apply the pre-processing rules first. Okay, let's see. So we can see that this is the initial state, and something is going into this initial state which should not be the state actually. And here final state, it is also unexitable final state. No, something is exiting from this state. So I have to convert these states into normalized uh, FA is states. So what I can do, I have to introduce another edge here, and then I can introduce null transition here, and I will remove the status of this initial state. For example, this is the newly initial state, and introduction of this null transaction, and this is now state number 2. And similarly for final state, introducing another state here with null transition. As you can see here, this is now final state and introduction of this null states. Now, this initial state is something uh, mm, in a normalized state. This final state is something in a normalized state. But now I have to check some multiple loops or multiple paths. There is no multiple loops, or though this is not the loop actually. Okay, loop is something originated from some point and ending at that point, same edge. For example, you can say I can go from 3 to 2 and then I can come again to this 3. This is not a loop. Actually, this is a loop. It is a cycle basically, but this is not a loop edge actually, like this one, like this one. So okay, so there are no loops, no multiple paths, uh, and unenterable initial state, unexitable final states. Uh, this one, unenterable initial state, unexitable final states, and there are no more than two initial states and no more than one uh, final states, like this. So all processing rules are done, and now we have to apply the state elimination algorithm, which is the removal of the states. And in first step, we are going to eliminate this state number 2. I can remove this state number 1 or state number 3. But okay, let's see what will happen if I will remove this state number 2 by eliminating 2. So if I will remove this one, incoming edges are 3, outgoing edges are 2. So 3 multiplied by 2 is equal to 6. 6 edges I have to introduce. So it is also a good strategy to always select that state uh, for which you don't have to consider too many edges. But this is the complex case, so that's why I am considering it uh, here for you people actually. So 3 multiplied by 2 is equal to 6. 6 edges I have to consider. Okay. From initial state, if I will remove that from this initial state, I can reach at 1 by using this path. So I can introduce one edge here. From this initial state, taking B, I can reach at 1. And similarly, from this initial state, taking A, I can reach at 3. For example, null. If I have A, null is automatic transfer, and then taking A, I can reach at 3. So that's why here in this figure, from this initial state, taking B, I am going here, and taking A, I am going here. I can use maybe the annotation here. So these are the two edges. First, I have done with. Okay. And now, from out of 6 edges, 2 are done now. And now think for other edges. So from this initial state, I can reach here a null B. And if I will remove this 2, from this 2, from this 2, or from 1 actually, because this is not going to be removed, but this is removed. So from 1, I can take A plus B and then B. So this is a kind of a cycle. And if 2 will be removed, then it will become a loop. But this is the path A plus B and B. So A plus B and B, which I have to represent it here. A plus B into B, and I have introduced a loop here, which is equal to this one. And similarly, at 3, I have B plus A and A. So this way, this is another way. So you can say B plus A and A. So 4 edges are now concluded. And now from 3 to 1, I can reach from 3 to 1. From 3 to 1, how I can reach, I can maybe I can use some other color. From 3, yes. From 3 to 2, I can use this path, and then I can use this path. So B plus A and then B. I can, so B plus A and then B, and then I can reach it, reach here at this edge 1. And similarly, from 1 to A plus B to this and A, I am reaching at 3. So this is that edge mentioned here. So 6 edges are now complete. And now I can clear my drawing and I can move forward to some other things. So now these edges are now complete, but still I have this initial state and final state. Still I have to remove this state 1 and 3, and at the end I will have this initial state, and then I will have that final state only, because these would be the two states which will remain at the end. Rest of the states will be removed, and when this state will happen, at that time I will get my regular expression finally. So now I am removing this state 1. Okay, so now I have to, so I am doing what? I am eliminating this state 1. So if I will not consider these loops according to the rules, so incoming edge is 1, and then 2, and then outgoing is 1. So 2 plus 1 mentioned here is equal to 2. And okay, if I will remove this, suppose if I will remove this from this initial state, I can take this B and then this A plus B into B whole star, and then A plus B into A, and then I can reach at 3. This is the one edge. And what is the other edge? I have to think. So from this 3, if I will remove this one, so from this 3, B plus A into B, and maybe this one. Maybe, but this is, let's see what will happen. I can change the color because green is not something. So one thing is sure, after removing that, how can I reach from this initial state to this state 3 using this path? So this B, and then this loop, and then this path is something that I will definitely need. So B, A plus B into B whole star, and then A plus B into A. This is one edge. So where you can see your edge now. So here B, here at the bottom, here B, um, where is the annotation? Yes. So here I am highlighting. So B, A plus B into B whole star, and then A plus B into A. So this is something. Now regular expression is going lengthier, so I introduced a new variable that is called y, and I said that this right hand side is equal to this new variable y. That I will use here uh, in my diagram. Okay. Maybe you are not looking properly. Yes. So from initial state to 3, this is A, and I don't have to remove this edge because it is something uh, not needed to be removed. This side is going to be removed. So okay, by, so I represented A and then plus B. I can take the either A, either Y, and then I can reach at where? Number 3. I can reach at 3. Okay, now this is the one edge. Now think for the other edge. The other one is quite easy. Now I want to clear this drawing first. The other one is easy. After removing this from 3, can I go here? Yes. From 3, I can take b plus a into b here. Then this loop a plus b into b whole star. And then a plus b into a. And then I can reach again at 3. So this is something you have to introduce at 3. So that's why here it is mentioned. This is the loop. So b plus a, this one here, a plus b whole star here, and a plus b into a here, and I can call it x. So this is the cycle that is again now removed, and it is started from the state 3 and it is ended again at 3. So you can introduce a loop label with x here. So now it's this loop b plus b into a is already existing, so I can introduce this as it is, and by taking this null I can reach it here. So this is the thing now you have introduced here. Now moving forward, so only one state is left between this initial state and final states. Now I have to remove this one. So now eliminate this 3. So this one incoming and one outgoing. So 1 cross 1 is equal to 1. So it means that after removing this state 3, I have only have to introduce one edge. So this is my initial state. This is my final state. I forgot to mention here the initial state and the final states. So initial states and the final states, I forgot to mention it here. And then you can say, okay, a plus y, and then this is x, and b plus a, you can call it z. b plus a, b plus a into a, you can call it z. So a plus a into this one concatenated with x, this is a loop, so it would be a star, and this is z as I mentioned here, and it would be a star. So x, or so x plus z, and then whole star. Due to this loop it is whole star. And null, you don't have to mention null, you can simply remove that null because now it is not needed anymore. And this is something, your regular expression that you want to achieve. Okay, and this topic is now concluded, that how you can convert an fa into a regular expression. I hope that you have now enjoyed this lecture. Anyhow, take another simple example now. After removing this annotation, okay, I have taken the sequence of for the elimination of state as 2, 1, and then maybe 3. But now you can change the sequence with 1, 3, and 2. You can change this sequence. So now try the same example with this one, 1, 3, and 2. So now I'm not going to remove this one. I'm going to remove this state 1. So 1 is 1 outgoing, 1 incoming. So 1 cross 1, one edge I have to introduce. And what is that edge? It is a kind of a cycle. So this will be removed. So from this 2, I can go B and then A plus B. So this is the edge actually I have to introduce. So this is B and AB. So this is the loop I have introduced now here. And this A and B, the rest of the things are same. Now eliminating 3, okay. I can eliminate 2, and then edges would be 1 and 2 multiplied by 1. Then edges would be 2. And if I will remove 3, okay, 1 and 2. So in both the cases, the edges will be 2. So previously I have eliminated this one. So now I am eliminating this 3 first. Okay. So if I will remove this one, then I know that from 2 I can take A and I can reach at final states. A and then null is automatic transfer, implicit transfer. Okay. And the other thing is, so two edges I have to introduce two edges. So that's why this is A and I can reach at final state. So that's why this is one edge with A and I can reach at final state. And the other thing is that I can take A and I can come back to this state to A into B plus A. And it is a star, it is a cycle. So I have to mention, not star, I have to mention it. It is a cycle, so I have to mention it with a loop. As you can see here, a into b plus a into b plus a, and I am calling it y, and I am calling this loop b into a plus b as x. So two edges are now completed. Now I have to eliminate this 2, state number 2. If I will remove it, then only two states will be left, which would be the our final stage, and it would be okay. I can ignore this null. So x plus y from this state, and it is a loop, so I have to mention star. So x plus y whole star, and then after taking a, which is mentioned here, I can reach at the final state. So this is the regular expression that I can get after removing states in a sequence like this one, 3, and 2. Now, this is your homework. You have to try these things by yourself. These are the two FAs given to you with initial states, final states, and different edges. And here, the initial and final state is the same thing. You have to exercise this thing by yourself. Uh, and I hope that you will submit these assignments via Google. Af- But that thing you can do if I will upload this assignment there. So wait for that one, and then you have to submit that assignment accordingly. And the other announcement is that this is the end for the um, this is the end of the course for your midterm examination. So after taking I will take the midterm examination till up to this topic actually, and after the midterm we will start this course again, inshallah. So so till that time, okay, take care of yourself. Allah Hafiz.